free closure. No. I bought a car.
There are so many. It's on Etsy. Don't question.
The what?
I have heard praises. I've heard my praises sung in the street. This is my favorite.
Okay, so we're going to get started, everybody. Part A, we have two categorical variables.
Oh, wait.
Number one, two categorical variables. That means use a chi-square test. Okay? Technically, there are two names, the chi-square test for independence and the chi-square test for association, but just saying chi-square test is fine. How do I know to use a chi-square test?
So we have to say it like how we're going to use it.
Yep. Okay, the other thing to remember, this happens when you have a matrix. Okay? And it has to be 2 by 2 or bigger. That's kind of your dead giveaway. If you have a 2 by 1 matrix, it's not going to be. It's only one categorical variable. One categorical variable. That means you're going to use a chi-squared goodness of fit test, okay? Yeah. Thank you. Okay. For our question, we have, we're going to use a chi-square test. With, let's see, we have a 3 by 4 matrix. Okay. Matrix is 3 by 4. So DF is going to be equal to 2 times 3, 6 degrees of freedom. Two types of chi-square tests. Create a table of expected values for question 2. So this is when you're going to want to use the, well, first of all, I should tell you that expected value is equal to row total times column total. This entire thing divided by grand total.
Can you explain again how we got the degree of freedom?
Yeah, it's just the number of rows minus 1
Oh, yeah.
times the number of columns minus 1.
So is
Or to find expected values for the whole matrix, use the cells program. And that's what we're going to do. We're going to use that cells program on the calculator. Thank you. So to take you through the steps, the first thing, go on to the matrix. We're going to edit matrix A, and matrix A is a 3 rows, 4 columns. Second, and then x to the -1. Then go to Edit. All right, so we're just going to put these in here, 12, 13, 34, and 25. 19, 25. 28, 28. 28, 29. 14, and 15. So that's my matrix A. Double check to make sure you have all the numbers in there correctly. 12, 19, 28, 13, 25, 29, 34, 28, 14, 25, 28, 15. That's good. That's everything. Let's screenshot this. Looks good. And let's use that cells program. Home screen. Program. Cells is program 3. Push enter. It tells you all the information. We're probably going to need that for questions 3 and 4, but we'll just put that aside for now. Andrew.
The program says it's undefined.
Oh, give it to me. Let me reprogram that. There you go, Andrew, try it. Okay, so we'll leave that there, and we'll go to the, we'll actually take a look at the matrices again. Oops. Take a look at the matrices again. And we'll go to Edit so we can see the entire thing. And remember, the cells program puts the expected matrix in matrix E. E stands for expected. Wow, nice.
Yeah. Can I get a practice test?
Yeah.
Oh my god, wait, what line are you in?
Toy Story. So I'm Jessie.
Aww.
Good
Who's
stuff.
doing it?
It's just styled by Joyce and Patrick.
You look really excited.
Oh, I'm so excited.
You
Look
don't
at
like your outfit?
No,
Wait,
it's
what
really
is-
hot and sweaty.
What did she say? What's her name again?
Miss B?
No.
Jessie?
Jessie, what does Jessie say?
Yeehaw?
Yeehaw? Yippee-ki-yay? No.
Are you gonna like something like this when you grow up?
No, no, we just walked down the hall. Like that. No, yeah, we just put our hands on our hips. That's it.
Oh, wow.
Tell the hairdresser she's a good picture.
Yeah, it's supposed to be messy, but they ended up just making it like not look good.
Yeah. She just needs to fix it.
I should fix it myself. I'm just gonna be like, I don't know. They're like, you can't leave the annex. And I was like, why not? What's gonna happen if I leave the annex? And look, I did. Nothing happened.
You're gonna get lost.
Nothing happened.
If you start hearing chains and the smoke monster appears,
It is very hot wearing this thing.
smoke monster.
It's,
Oh, the tag.
yeah, we're not supposed to take them off because this is all boutique clothing. So I have to keep my arms down when I walk. 'Cause
Maybe you
okay,
just tuck it into the shirt.
have fun.
You have another tag sticking out.
Why?
You should tuck that in.
All right, let's take a screenshot of this so it'll be easier to write down.
Of what?
Here's our expected matrix.
Okay, after we get the chi-square test statistic, how do we, I've got
Alright, so you're just gonna,
Expected value.
okay, so push enter to quit the program and go to matrix and then edit. And you want to edit number 5, which is E. And you're just going to use that to look at it and copy it down on your paper.
Question, what's F? Matrix F?
Matrix F is the contributions to the chi-square.
So we're not going to be using it at all.
It's possible. I think we're going to have to use it later. Yeah, we are going to use it. So the expected matrix is that 18.3, 20.8, 23.6, 21.1, 21.8, no, 21.9, 24.8, 28.1, 25.2, right, and then 18.8, 21.3, 24.2, 21.7. So that's my expected matrix. I probably should have put columns and rows here. Let's just do that now. So this is what? B1, B2, and B3. This is A1, A2, A3, A4. So that's my expected matrix. Remember, it's just as valid for you to reproduce the entire matrix and put the expected values in parentheses. That's fine also. Three, what is the chi-square test statistic? Okay. Chi-square test statistic, let's go back to the home screen. And I just ran the cells program, so that gave it to me right there. It is 24.7. So chi-square is equal to 24.7. Easy. Question 4. Which one contributed most to the chi-square test statistic? Okay, so the contributions to the chi-square test statistic are in matrix F, and this is what you've all been asking about, that matrix F. So after using the cells program,
May I have a review sheet
yeah.
for the test on Monday? Hey, what's up?
Okay, so let's take a look at that. So we're going to go to Matrix menu, Edit, and we're going to look at Matrix F. Let's screenshot that so we're not going to keep flipping back and forth. Here's Matrix F. And basically, we're taking a look to see which of these is going to be the biggest value. Which of these is the biggest value? This one's tempting right here because you see a 7.8 times, but you see the E negative 4. So that's going to be wrong if you pick this one. Remember, that's 0.0007. So it looks to me like the biggest contribution would be this one right here, 4.53. 4.53, no, 4.54. The biggest contribution to the chi-square test statistic is 4.54, from, and that is A3 and B1. Okay, remember A3 means the third row, B1 is the first, sorry, maybe I got that backwards. A3 means the third column, B1 means the first row.
I'm really confused on what this means, the biggest contribution.
Okay, these values, let me tell you what these are then. The values in matrix F are they're all, what is that? Observed minus expected squared divided by expected.
It's just kind of like a sigma in a way.
Kind of.
This is for F.
This is from matrix F, yeah. But see what those all are? Those are all the little bits that you added together to get the chi-square.
Right.
So if you added all of these numbers here together, you would get that, I forgot what chi-square was. I think it was 24. Yeah, it was 24.
This is what you'd use in the equation with this sum of.
Right. Okay. So if you added all the values in matrix F, you would get the chi-square test statistic. So those are all the pieces that make up the chi-square test statistic. And a bigger number indicates that you are farther away from the actual value, or from the expected value.
What is a like, if we're saying one standard deviation, right? What would be comparable to that?
There is no comparison to that.
Okay.
Yeah. Yeah.
If you added up all the numbers in another matrix, like matrix E, it wouldn't add up to chi-square.
No.
It would add-
No. If you added everything in matrix E, because that's the expected values, you would just get the grand total.
So only F would get the correct number.
Well, it would give you the chi-square test statistic is only computed, or is computed most directly from matrix F. So that kind of takes care of that. Any other questions with this one, the expected matrix, contribution matrix? Okay,
So that's all we do, right?
that's it. All right, let's take a look at question 5 then. 5 says, using a suitable null hypothesis, the expected frequency for the cell for fatal accident and a small automobile. Fatal and small auto. Okay. So that's going to be fatal total. It's going to be the fatal total times the small total. This whole thing divided by the grand total. So what does that tell me? What is the expected then? Expected is going to be, what is the fatal total? How many fatalities are there? 137? How many small automobiles are there? 223 divided by, what's the grand total? 374. So that's going to be the expected for that one cell. 81. What are some alternative and null hypotheses? Oh wait, are we ready to move on? Can I move on?
Yeah. Great.
Suitable. Now, first of all, is this one or two categorical variables? Yeah, this is a two categorical variable, right? Two categorical variables. Fatality and car size, right? So H naught. There is no association between accident fatalities and car size. An association, the alternative is an association exists between accident fatalities and car size. And this is always what we're doing when we're looking at a two categorical variables. We're just seeing if there is an association between them, or is there not an association between them. It may not be a cause and effect relationship. Question 7, we kind of looked at in class. So we're looking at all the p-values that are created from these chi-square test statistics, and we're trying to find which is the one that will, the smallest one that will lead to a rejected null hypothesis. And if you just calculate all the p-values, you should be able to get to that.
How did you get all the p-values?
Use the chi-square CDF. No, it's not a program. It's a calculator function under distribution.
If you go into go to distribution, go to second distribution, and you go down, see that
CI.
it looks like an X with a chi.
Okay, so they give us a chi-square test statistic in the next table. The chi-square is 8.663. From the data in the question, chi-square test statistic is equal to 8.663.
Mr. Furrier,
Mhm.
I have a question about the last one.
Oh, sorry. What?
I'm sorry.
What are we talking about?
How do you get the degree of freedom?
Well, we're presumably doing this for the question about death frequency
Yeah.
and automobile size.
Yeah.
So we have a 2x3 matrix, 2 rows, 3 columns.
Okay.
So to get the degree of freedom, you're going to say 2 minus 1 is 1.
Okay.
3 minus 1 is 2. 1 times 2 is a degree of freedom.
Okay. Okay. I'm sorry. So you said
Number of rows minus 1
okay.
times the number of columns minus 1.
Oh, times the number of columns minus one. Okay. Let's do this.
So we do it for each one that's given?
Mm-hmm. We all good? Okay, let's calculate a p-value then. We're going to do the same thing. We still have 2 degrees of freedom. So we're going to use a distribution. Chi-square CDF is right there, number 8. So we'll push number 8. Our chi-square test statistic is 8.663. Remember, that's given to you in the chart. Don't mess around with the upper. It should be 1E99. You have 2 degrees of freedom. And that gives me 0.0131. Okay. That's my tested. That's my p-value right there.
I'm sorry, for 8, this is the approximate p-value for what? What is the approximate p?
They gave you the chi-square test statistic in the problem.
Where?
What's the chart on the right?
Mm-hmm.
Oh, is that problem? Oh, sorry.
That's fine. So the p-value is going to be equal to the probability that chi-square is greater than 8.663, which is equal to 0.0131. That's all of it.
And it's always going to be greater, right?
It's always going to be greater.
Have a good weekend, guys.
Have a good weekend. Bye-bye. That's it.